All right, welcome. This is for your project in terms of using sine and cosine and just getting practice with amplitude, midline, period, etc. This is going to be a little challenging just in terms of finding information and then using the pieces, especially like right after going over just the basics of each piece. And so if you get frustrated, take a deep breath, walk away, come back. But again, this is really just meant as a way to be able to play around with the features on Desmos and have some kind of background problem that you're trying to solve and kind of work with. And really just, again, familiarize yourself with the general graphing form. I promise we will look at more concrete examples, and I will show you a lot more practice and work and exercises in graphing these and being able to write the formulas given the graphs and blah, blah, blah. But I want you to find some and kind of work through some data. So this is kind of the application moment. And so what you'll see right now in the video is this is what I'll have typed up. You'll find this on PowerSchool Learning, but this is your project. What I want you to do is go through, and we're going to model specifically temperature right now, just to kind of have a central problem that everybody can deal with, so that way you can kind of help each other if need be. But what I'd like for you to do is to go through and actually pick a city anywhere in the world. It can be anywhere that you want it to be, preferably something different if you are going to work with friends. And I want you to go through and I want you to collect data, specifically the average monthly temperatures between 2016 and 2018. So we're going to look just between these essentially we'll say 3 years. So 2016, 2017. Well, 2 years, yeah, 2016 and 2017. Um, we won't run more than that, just because that'd be a lot of data points. So here I'll alter that right there, and let's make it the years 2016 and 2017. Um, and then when you find this data, which would like Google it, go through and try to find like a reputable source, the Weather Channel, etc. What you're going to do then is go into Desmos and you're going to create a table and then input this data into the table. And the reason why I want you to do it that way, I will show you here. I have my table on the left. This is the average monthly temperatures for Atlanta. So again, I don't want you to do Atlanta. You do need to pick a different city. And so I went through and I found the monthly temperatures, and I started with one is January of 2016, two would be February 2016, etc. After the number 12, which is December, 13 would be January of 2017, and then going all the way down. And I put then my average temperatures, and then it plotted out my points here. And if you notice, the points and the temperatures create essentially a sine and cosine wave. So that means if I want to get a curve that best fits this data, then I need to use a sine or cosine function to do that. And so that's the next step. So once you collect all your data and you get this plugged into a table on Desmos, go through and actually you can create literally the general graphing form for sine and cosine. So literally go through and type in y is equal to a cosine, parentheses b, x minus h plus k, or you can use sine. It's completely up to you. And then we can actually like play around with the sliders after you click add slider to create a graph that'll match my data as accurately as possible. So for example, let's say I put the vertical shift down to 0. Remember, that's what K represents. I'll plot this. So like normally, the wave is going to be way down here. Well, I know that the middle of the graph isn't at 0 anymore. It should be up near where my numbers are. And so I'm going to literally move it until it matches. And so this is what I mean by essentially playing around with it. And then, oh, well, this isn't going to fit. I need to compress it. Well, that's horizontally. I'm affecting its period. Well, that's B. So I need to shrink it specifically to a certain value and say, okay, well, that's getting closer, but my amplitude's off. So let's play with the amplitude now, right? And then, well, my horizontal shift is a little bit weird. So I need to fix the shift. Or, oh, okay, well, this is getting a little bit closer, right? So going through and playing around with the sliders. And again, my goal with this is that ultimately it'll give you a better understanding of what A, B, H, and K are doing to sine and cosine before we dig more into it, and especially into data that you have. As you play around with it, when you get to your final numbers here, the question that I want you to ask yourself is there a better way, right? Is there a more efficient way instead of just playing with the numbers? Is there theory behind it? And the answer is yes. So, like using your numbers, how could you find amplitude? And think about what we've done previously so far. How would you find B? How could you determine your H? How could you determine your K? And write that out in terms of that process. And so if that's not a step here, then I'm going to go through and do that. Find a function that best models your data, and then we'll break down into a little bit more of that kind of steps and process. Your ultimate goal is once you get your model, use your model. Um, what would the temperature be in March 2021 in your city? So next year, can we predict what the temperature would be? Better yet, if you want to use your model, what would the temperature be in April of 2020? And by the end of the month, we can kind of see if the monthly average turned out to be that or not. So that is your project. If you have any questions, let me know. And you'll have about 2 days to kind of work through this before we continue and move on through.